Hey, welcome to Chapter 10, Section 4, about inscribed angles. This is for the second half of geometry, and we're going to talk about inscribed angles today. And just a quick reminder, you can always pause the video, rewind it. I'm just going to keep going along, so it's bad enough that I'm sitting in a room talking to no one right now, and that's why you might hear music in the background. So, inscribed angles. Okay, you guys can read the definitions there. I'm going to talk about some things about the angle here. So we're going to talk about angle A right here. And angle A is on the circle, so that's why it's inscribed. It's inside the circle, but the point A is on the circle. So we're talking about this angle here. So when it talks about an angle, the vertex is on the circle, that's what it means, okay? We could call this angle BAC. Remember, the middle letter is where the vertex is at. So this is the inscribed angle that we're going to talk about here. So down here in the inscribed angle theorem, so this one here, we're going to talk about this, and that's kind of what this whole section is about, is understanding how the arc of the angle, so this is the arc, okay, and it's an intercepted arc. So as I follow the leg or the sides of this angle, I see this arc. So I probably should use a different color. So this is the arc that's intercepted by the angle. Now there's a relationship between the angle and its arc. Now we talked about central angles before, and a central angle is here in the middle, and it might look something like this. Well, we've talked about the central angle is equal to its arc. Well, if you think of it, this angle is twice the distance away. It's away on the other side of the circle, so therefore the arc is going to be twice the measurement of the angle that's way over here. So you guys can think of a number in your head, but I'm going to show that this is a 60-degree angle down here, or a 60-degree arc. And if that arc is 6 degrees, well, what's this measurement? Well, the measurement is going to be half of its arc. So this measurement of this angle is 30, because since the arc is 60, the angle is going to be 30. Now we could switch that around, and let's say if we have an angle at angle A, and we're going to call that 40 degrees. Well, what's the arc going to be? Twice that measurement. So now this is going to be 80. What would the central angle be, since we have that drawn? Well, the central angle is still going to be at 80. It's going to agree with its arc. So central angle is equal to its arc. The inscribed angle is going to be half of its arc, or the arc is going to be twice as much. So let's go through a couple of problems here today, and I'll try to keep this short so you don't have to watch a long video. All right, so here's the next one. We've got a few problems to solve. We have to find all the angles of the 1 through 5 here, and it gives us some information about UW is 20, XY is 40, and I know that's not drawn correctly, but we'll go with the numbers. It's totally made up. I guess I could switch those numbers around, but we're all good. So that's not the point of this. It's just making sure we follow back to the angles. And UZ, this is kind of going through two places. It goes past T, and that is 108. And we'll use that here in a little bit. So clear that up a little bit. There we go. All right. So, and UW is the same as YZ. So again, doesn't look the same, but we're going to say that's 20 also. Okay, so let's go in order. Angle 1. So as you do this, follow the sides of the arc, or the angle, to the arc. So this arc is 20, so what's the angle? Well, it's going to be half of that. So the measurement of angle 1 is just going to be 10. What about the measurement of angle 2? Well, follow its sides. That's going over here. Now, I know it looks smaller. We're going to go with the numbers that are given to us, because that's what we do. This is going to be 20. Okay? Because the arc is 40. The angle is going to be half of it. Now, 3 is here. I'm going to switch to blue here. So if I follow that, that goes to U and to Z. What's its intercepted arc? Well, it would be this, that's 108. Well, the measurement of angle 3 would be half of 108. So if you think of it like this, 108 divided by 2, well, what's that going to be? 54. Okay? So, and I apologize not writing it down before, but I think we can grab a calculator, divide by 2, or we can do it in our heads. Angle 5, I'm going to do angle 5 real quick. I'm going to jump to that one before we tackle angle 4, because angle 4 is kind of floating around in the middle of nowhere, but it's not as hard as you think it is, and you guys have seen it before. But if we follow angle 5 actually goes to the same arc as angle 3, and we're going to talk about that a little bit later, is if two angles share the same arc, well, the angles have to be congruent to each other, because again, angle 5 is going to be hitting the arc of 108, so therefore what's half of 108? 54. Okay? Now, angle 4, I'm going to bring it over here and let you guys see this real quick. Angle 3 is 54, and angle 2 over here is 20. Well, now we see that angle 4 just makes a triangle with those two. So I had to draw it kind of over there because I know my football play here is getting kind of messy. So we'll clean this up a little bit. And you guys can see the triangle right here. And this is 20. This is 54. Now, 20 plus 54 is 74. So 180 minus 74 gives us 106. So that is what angle 4 is. So the measurement of angle 4 is 106. Okay? And there's no half of there. It's not an inscribed angle. It's not on the circle. And there's other ways to do it. We're not going to get into it right now in this lesson. So, but that's why it makes a triangle. And we've been doing a lot of stuff with triangles. So that one works out just fine. And then this is just calling back angle 3 and angle 5 from the last one. We said they share the same arc. Well, here A and B share the same arc. So therefore, angle A is congruent to angle B. Because they share the same arc. And the same thing would go true is if the two angles or two arcs are congruent to each other. So if this arc EF is congruent to arc CD over here, if they're congruent to each other, well then we would know these two angles are congruent to each other also. So again, just going back to that relationship between the angle and its arc, we did a lot of angles on its opposite side in a triangle. Kind of works the same here with an arc. Inscribed angles, and we talked about this real quick the first day, is if we pick a point anywhere on this circle, so I'm going to pick my point right here, and if I draw a line from that point, from point A, and then that point to point B, well, what's this measurement going to be? Well, what's its intercepting arc? The arc is right here. Well, if AB is a diameter, this has to be 180 degrees. So what does that arc have to be? Or this angle has to be? It would have to be 90. So, and that's kind of, I think, a unique thing about this in circles is no matter where I would put that dot to draw that line first, you know, if I put that dot way down here closer to B, again, if we take, and you got to use your imagination on my straight lines, but there we go. And here, again, this would be a right angle because its arc is 180. Half of 180 is 90. And then we could get into some problems where here's AB as a diameter again. Well, what do we know? We know this has to be 90 degrees. So what do we know about angle 1 and angle 2? Well, measurement angle 1 plus the measurement angle 2 must equal 90 because 180 degrees in a triangle. So if we set this problem up, 12x minus 8 plus 3x plus 8 equals 90. Well, the 8's will just cancel each other out because they're positive, negative. 12x plus 3x, 15x equals 90. So x equals 6. So I plug that back in, and I get 72 minus 8, which would be 64. And so measurement angle 1 is 64 degrees. And plug 8 or 6 into angle 2, and it'd be 18 plus 8, which would be 26. And if we add those together, we get 90, which that's what we wanted. And then down here in the bottom, it says arc AD is congruent to arc DB. So this arc is congruent to this one. Well, again, angle 3 intercepts with this arc, and angle 4 intersects with this arc. So therefore, this arc and this, or those two angles, are congruent to each other because their arcs are congruent. And since this is a 90-degree angle here, again, because AB is a diameter, this is a 45, 45, 90 triangle, which I'm sure some of you guys are cringing from chapter 8. Just kidding. So we can make that connection real quick. And then last thing, and we'll try to get this done. I know the video is going a little longer, but W is 95 degrees and Z is 60. And what our question is what is measurement Y and what's the measurement of X? Well, if we follow 95 degrees, 95, or the angle 95, goes to this arc all the way from Z to X. And it'd be double that, so 95 times 2 would be 180 or 190. So if that's 190 over on that side, what's this arc? And we'll do that one in blue over here. What's this arc going to be? Well, 360 minus 190 is going to give us 170. So this arc here is 170. So the angle over here has got to be half that much. It has to be 85. Now, you could make the connection, and this only works because it's an inscribed quadrilateral, and that means a quadrilateral inside of the circle, but their angles are going to have to equal 180 degrees. Opposite angles are going to have to equal 180 degrees. So same thing here applies. If this is 60, well then this arc down here is 120. Well, what's left over? 360 minus 120 would equal 240. And what's half of 240? 120. So our angle X is 120 degrees. And this might be a long one. You probably get along done. Kind of get the hang of it already. But this just brings a point that a quadrilateral adds up to 360 degrees. All four of the angles added together equal 360. Well, if I would give each one of these a separate, its own color, so I give angle Y red and angle X green, and I guess W is going to be black. But W's arc would go from here all the way to X. And Z would go from Y all the way to W. X would go from Y to W, and Y would go from Z to X. And anywhere you look around this, you'll see that there's two lines going around the circle. Well, we went around the circle twice, or 360 degrees times 2, which would be 720. But remember, all the angles would be half of that. Well, what's half of 720? Well, we just took it times 2, so therefore it'd be 360. And that's another reason why quadrilaterals will add up to 360 degrees, or another way to show it. So, thank you, and follow along to Chapter 10, Section 5 in a little bit. Thank you. Bye.